Hello, ELT 132. This is Roger Young, and this is a class activity, an online class activity. And the subject of this video is going to be on binary. Specifically, I want to go over the comparison of decimal, which is base 10, to binary, which is base 2. Okay? Because when you understand this, everything else can fall into place. If you don't quite get this, then everything else is much harder. The good news is you do this all the time without even thinking about it, that's wonderful, isn't it? So I went to the presentation, and I wanted to go over the classroom presentation I'm referring to. And I'm looking at an example I give you about decimal. A decimal value of 25. Just think about it. What does that mean? I'm sure you all immediately can think about what it means because it's base 10. That's what you use all the time, right? So, I mean, you can think of it like 25. You can remember your 25th birthday, right? I mean, well, maybe. I can't remember mine. That was too long ago. But you know what I mean. The 25th birthday or 25, I don't know what else goes with 25. Think about it. But when you look at this number, 25, right? What do you have? You have two columns here, right? There's a column here with a 5. That's the ones column, right? And the column here with the 2. That's the tens column. If you had another one here, that would be the hundreds column. And to the left of that would be thousands, and then 10,000s, right? It would keep on going. But where does that come from? And where it comes from is this column right here, which is the ones column. That's actually 10 to the 0. That's your 10 to the 0 column, and that's what's shown right here. 10 to the 0 is actually equal to 1. Remember that. Almost anything to the 0 equals 1, okay? So if this is in the 10 to the 0 column or the ones column, what we're saying here is this column is 5 times 10 to the 0 or 5 times 1. This column where the 2 is not 10 to the 0, it's 10 to the 1. 10 to the 1 is equal to 10. Get it? So 2 times 10, this would be equal to 20. If we add them together, obviously 2 times 10 is 20, 5 times 1 is equal to 5, and you add them together, you get 25. This is a very basic example, and this is how most of us communicate on a daily activity, right? We daily communicate with others this way using decimal. But now, what about binary? What are we doing? We're going over here. Let's go to binary. There we are. So, in general, binary, right? Binary is base 2. All right? On or off. Think about it. That's all a circuit knows. It knows if it's high or low, on or off, right? Binary. So, I'm giving you the actual number of 25 that represents 25 decimal in binary. This is 10011. That is equal to, in binary, that is equal to 25 in decimal. All right? So let's go down into this further. Let's think about this. Why is that so? Well, let's deconstruct this binary number. Let's go by the columns, right? This column is 2 to the 0, right? Which is equal to 1. There it is. You see it over here? This column here, why am I not getting my, there it is. This column here, this is 2 to the 1, isn't it? So here you go, 0 times 2 to the 1. This one here is 0 times 2 to the 2, which is right here. This is 1 times 2 to the 3, right there. 1 times 2 to the 4th, which is right here, right? So if you think about it in another way, this is the ones column, this is the twos column, this is the fours column, this is the 8 column, this is the 16 column. Do you notice a pattern there? They double, don't they? 1, 2, 4, 8, 16. If you had more, it would be 32, 64, 128, 256. You just keep on going, right? But for this example, let's complete it now so you understand where this row came from, right? So all we did for the next row is we just simply rewrote it. We wrote 2 to the 0 is equal to 1, so that's what we wrote here, 1, right? The next one, 2 to the 1 is equal to 2, isn't it? Let me get it over here. 2 to the 1 is equal to 2, so there you have it, there's your 2. 2 to the 2 is equal to 4, there's your 4. 2 to the 3, it's 8. 2 to the 4, it's 16. You see, we just rewrote them, that's all we did. No changes. Now, if you simply complete this row, 1 times 1 is equal to what? It's equal to 1, isn't it? 0 times 2 is equal to 0. 0 times 4 is equal to 0. Here we go, those two. 1 times 8 equals 8. 1 times 16 is equal to 16, right? And 16 plus 8 plus 1, what do you have? 25. All right? So there is the difference. If you need to go from binary to decimal, this is how you do it. You simply write the binary number and you fill it out as I did here for each column, right? The example, they ask, what is this in decimal? I'm sorry. 0, 1, 0, 1. Do you notice I'm always saying the number from right, which is the least significant digit, to left, which is the most significant digit? Where do those verbs come from, or those words, how did they come up with those? What is this equal to? What column is this? It's the ones column, isn't it? What column is this one? Well, this is 1, this is 2, this is 4, this is 8. This is the 8th column, right? It's more. A change here is much more significant to the number than this one. That's where they come up with it. But let's use the same exercise. Do you see where this came from? This is 0 times 2 to the 0, which is what you have right here. This is 1 times 2 to the 1, right here. 0 times 2 to the 2, which is listed right here. And 1 times 2 to the 3rd, which is listed right here. And then they just simply completed this, and 0 times 1 is 0, 1 times 2 is 2, 0 times 4 is 0, 1 times 8 is 8. They just forgot the 0 portions, and they just use the 8 and the 2 here, and that equals 10. So the next example, very similar, except it just has fewer bits. That's equal to 7. How did I know that? I didn't even look over here. This is the 1's column, the 2's column, what's this? The 4's column. 1 plus 2 plus 4, what is it? It's 7, right? And they use the same method here. I hope this has helped you understand the method that is used to evaluate a number based on the numbering system. That is really what we're doing here. When we talked about hexadecimal, all we did is we changed the base from base 2 to base 16, but the same method was still used. That will come up in another video. Well, thank you everyone, and I hope this has been helpful.